All right, welcome. This is the AP Physics 1 Force Review Sheet Solutions. Here I'm going to go over Section 4, which is the free response. Okay, you see the scenario. All right, block, horizontal surface. There's a force of friction because there's a mu, tension, Ft. There's a theta. It's being pulled on a theta value. You're going to draw and label all the forces acting on this crate. All right, so start by drawing your object. So I can make it here square. I could try to make it a square. Alright, so here, that's the center. A couple things that you have on the diagonal. You have F of t going down. You have force of gravity going left. You have your F of friction. Okay, and going up, you have force normal. Another way you can have this, you could also draw it like this. This would be also be a valid answer. Okay. Sorry. T. This is. You wouldn't use weight. Here you can use. I think you would just have to use force of gravity here. Here you can move. You could write it as this force of friction. Up you can use N for normal. Okay, these are all correct. Do not draw the components. Okay. All right. Okay. So B, compute the normal force acting on the crate. I'm just gonna steal this because I have to redraw it. Okay. Oh, sorry. Okay. But I need a couple things here. Okay. I need a. It's broken up into its t cosine theta, and there is a t sine theta here. All right. I'm just breaking it into its component form. All right. You want us to compute the normal force acting on the crate. Okay. So here, force normal is going to be equal. Okay. Um, let's just. Yeah, I'm going to set it up from the original. To me, it only makes sense if I start it up from mass times acceleration. Okay. Um, so here, let A be 0, so it's in equilibrium. The force net here, the only thing in the right this we're looking for the force normal part. So I'm only looking at the vertical part here. Okay, because that's where the normal force is. So I have normal minus mg plus t sine theta equals to 0. Okay, so then the normal force would be solving for n. Okay, again, I don't need to write force of tension, and I don't need write t cosine theta. Okay, those are its horizontal part. They both can cancel if all I care about. I just want the normal force. Right, start what F net equals to ma. So n. I could add these to both sides. Let me show you the algebra in case some of you freak out. Okay, add mg. Add mg. Okay, get n plus t sine theta is equal to mg. Subtract t sine theta. Subtract t sine theta. you get normal force is equal to mg minus t sine theta. So the normal force is equal to the mass times gravity, quote unquote weight, minus the tension force in the sine direction. The sine direction just means the tension in the vertical part. Okay. You want to compute its acceleration here. Here you want basically all of it. Okay. All right. And so here we're looking at the horizontal part because it's the acceleration and it's on a horizontal surface, right? Horizontal surface. Okay. You want the acceleration. There's multiple ways of doing this. So I'm going to set it up from F net. Okay. So F net is equal to A of the system times the M. So divide M to both sides. I get here A is equal to F net is equal to M. Okay. So the only M here that I have, okay, is just the M. What are the force nets here? All right. So in my horizontal part, I have the first of all the T sine cos of theta. So I have the force applied. So that is your T cosine of theta. Okay. And again, I'm doing this. Force of friction minus force of friction. But what is force of friction? Force of friction is defined as mu normal. But what is the normal force? Mg. But what is the normal force? Okay, oops, sorry. Let me say that. That's the normal force. But what is the normal force? The normal force is this. So what do I substitute in here? Mg minus T sine of theta. Okay. There you go. This is the normal force. You had to get it up here. Good? There you go. That's your answer. Your acceleration is equal to that. Okay? 2. That's it. That's it for the first question. 2. Draw and label all the forces acting on block 1. So we have this. Okay? Is it frictionless? Yep, frictionless tabletop. Okay. So we have mg, which is force. So we can just force of gravity here on m1. Then we have force normal, so n, and the force applied. In this case, it is the tension force that is being pushed because this is the rope. Please remember that there's no force friction. Okay. Block 2. Okay. There's a force being applied forward. Okay, that is the F. So here we have force applied. Then what is going down? We have this one, force of gravity. But this is on the second object. Please understand that. And on block 2. So this is because here if you just write FG and write FG, right? They think it's the same. So this is M1, right? So you could write MG1, and this is M2. So you just write FG2 here. Okay. Then up is the normal force. If you write the normal force, they think it's this one. So here you could write normal 1. Here you could write normal 2. Okay. Then in the back, right here, there's that rope. So there is that tension. Okay. Please understand that anything up and to the right is positive. Okay. C. Okay. What is the acceleration of block 1? So, you want to find the acceleration of block 1. Okay. Please understand that acceleration of the system is going to be equal to A1 is equal to A2. Okay, so all you have to do is I would set up F net is equal to M net, sorry, A M sys and A sys. Okay, so here, what are my forces? Horizontally, I have my force applied. That's all I have. Okay, I don't have the force of gravity cancels out with the force of normal. It's equal to, what are my masses? M1 plus M2. What is my A? That's just A of the system is just A. Okay, divide that over. You should have force is divided by M1 plus M2 is equal to the acceleration. Okay, that's A of sys. So that's also A of 1. So you can write A of sys here, right? But you know A of 1 is equal to A of sys, so you could write this is also equal to A of 1. Okay, so this is really bad for the graders. So you could write, don't write it like that. You can just write, so A of 1 is equal to M1 plus M2. Okay, what is the tension in the string connecting with the two blocks? State your answer in terms of M, F, M1, and M2. You have the acceleration, so just plug it back in. Okay, so tension is equal to mass times acceleration. Right, tension is equal to, what is the mass? Just look for M. What is the acceleration? We have it here, which is just F over M1 plus M2. Okay, there you go. There's nothing iffy about it. I grabbed the acceleration here and I threw it in here to make the substitution. That's just the mass. Okay, you could say mass 1 if you want. You could also put mass 2. Okay, same thing. All right, the tension here, oops, the tension here are the same. Okay, these two would cancel out, tension and tension. Okay, tension here and tension here. Part E, if the string connecting block 1 was not massless, but instead has M, determine the acceleration of block 1. Okay, so if the string was not massless but had a mass M, so how it looks like, first of all, you want to picture this, is that there is this mass M1, then there is a mass M2, and there's also there's a mass M3. This is the new mass. Oh, so they just wrote M. Okay, so this is still M1, M2. The new mass is M. Okay, all right. That is the string. Okay, but that's how you want to picture this. This is the block mass. This is the string's mass, and this is the second block's mass. All right, what is the acceleration? Again, just set it up. F net is equal to MA. Rearrange, A is equal to F net over M. Please understand this is M of the system. So A is equal to, what is this? So this is just M1 plus M2 plus M3. Okay, you just have to determine what F net is. Okay, all right, so what is the only force in this whole scenario going to the right? Just F. All right, which is just the force applied. There was no other force. Okay, there you go. That's your answer. Okay, that's what happens when you introduce a third mass. Okay, so if you want to have a side note here, okay, I could type this out much better. Okay, notice that the addition of a third mass will overall decrease the acceleration. Okay, that is my claim evidence because the numerator is larger, reducing the fraction to a smaller value. Okay. All right. The difference between the strength of the force that is connecting string A and string 2 if the force connecting the block. Please state your answer. The difference in the strength of the force connecting the block. So here, what they want, this is interesting. So what they want here is the difference between the strength of the force connecting the string exerted on block 2 and the strength of the force connecting the string block 1. It's not a stupid question, they just word it differently. Right? This force connecting the string on block 2, that's just tension of 2 on 1. Force connecting the string exerted on block 1, that is just tension on T2. Right? Okay. So if they're looking for the difference, they're looking for the tension of 2 on 1, subtract tension on 1 on 2. That's just going to be equal to what is the okay, right? So this will just overall be the acceleration. Okay, so this just overall will just be equal to, again, mass times acceleration, but we know that the acceleration is this, correct? So this be equals to m parentheses f over parentheses m1 plus m2 plus m3. Okay, there you go. You're just dropping the acceleration right here. There's nothing involved. There you go. So the tensions are like that. That's the difference in the tensions. Okay. That's it. 5. 4. Wait, hold on. Did I not? Hold on. Did I not grab the other one? Oh, this is the. Okay. All right. Give me a second. I gotta set up question 3. All right. So this is number 3. Okay. Here you go. You have this scenario. If the surface of the inclined plane is frictionless, determine the theta that will cause the box 1 to accelerate up the ramp. Okay. All right. So you want to basically solve for an acceleration value. Okay. So understand that you can start the equation from F net is equal to ma, or you can, right after you do that, you get acceleration is equal to F net divided by, please understand this is the system. Okay, so the m here, right, it's just m1 plus m2. Okay, you need to know what the F net is. Okay, all right, so what we can do is just grab some things up here. Okay, so let's draw this one. We have mg. Likewise, we have this part, which is just mg. We have this. This is the sine part. So this is the mg sine part, and this is the mg cosine part. Okay. Good. The way it's memorized is that mg cosine theta is always shared with the normal force. Likewise, here, there's also force of tension this way. There's also force of tension this way. And what is going down here is the M2G. So what are my F nets here? Okay, so there's nothing horizontally. Okay, the N and the mg sine theta and the N and the mg sine theta, okay, are both this way. The object doesn't move that direction. Okay, so this just kicks out. The only thing that you have left is you have the mg sine of theta part. Okay, and then you have the, which is in blue, green, M2G part. Okay, so one of them has to be positive, one of them has to be negative. So if this is accelerating, I'm going to treat this as positive. Okay, so this is going to be positive, this is going to be negative. Okay, because again, we want this to accelerate up the ramp. Okay, you can pick your signs anyway. So the two forces that I have here are the force of gravity pushing it down, pulling it down. So I have M2G. Then I'm going to have it minusing mg sine of theta. Okay. If you would like this simplified, it can be written as m2 minus m sine of theta parentheses g over the m1 plus m2, the mass of the system. That's also the acceleration. Okay, that's what needs to occur. Right? Determine the values of theta. Okay. All right. So, okay. So for A to be positive, okay. So for A to be positive, so for A to be positive, okay, we need you need to have this be greater than 0. Okay. So you would have to do some. I hate doing this, but I guess we have to. Okay. Here's some algebra. Okay, because I have to solve here. Once you have this, this is an acceptable answer, but they want to solve for theta. So I'm going to multiply that across. So there has to be an acceleration, right? So, okay. So M1 plus M2 acceleration equals to divided by gravity. So it still would be minus m sine theta. And there's an m2 here. Okay, so I just divided by m. Okay, divide by g, and multiplied by m1 plus m2 to just get the top term. Subtract that over, so that would be just m1 plus m2 a minus. So this is all on top of, sorry, this is a all on top of g. This is minus m2 equals to m sine theta. To solve for theta, you would have to divide this by what? M. Theta. You would have to sine inverse all this BS. So all this in here. This is the stuff. Okay, all this stuff goes into here. Okay. Yeah. Okay. Slide up at a constant speed. This one's easier. Because if you want it at a constant speed, we know that a is going to be equal to 0. Okay, a is going to be equal to 0, and you could just equivalently just do this. Okay, so in short, the answer for this would be that sine inverse. You want that to be you want theta to be less than sine inverse of m2 over m1. Okay, and then here again you said equals to 0. Work all that out. It's the same math, but in the end here you're going to get 0 because it's at constant speed. This is what it equals to. Okay, so it becomes m2 minus m1 sine of theta is equal to 0. So you want sine inverse of m2 over m1 is equal to your theta. So this is the sine inverse of the ratio of mass. This is going to be your theta value. Okay. Right, but it's the same part from FNet here. All right. And is that it? I thought there's a part B. Okay, hang on. Yep, there is a part B. Okay, I'm going to read it to you. Let me bring it up. Hold on. All right, here's the part B part. The coefficient of connection between the surface and the inclined plane and the mass of M1 is mu k. Do not derive but do not solve. An equation satisfies with the value of theta, which will cause the box of mass 1 to slide up the ramp at a constant speed. Okay. So, I actually did most of the work up here. Okay. So, you have the Fnet is equal to MA, and this is M of the system. Okay. All right. So let's just break this down. This is M1 plus M2 is equal to the acceleration. We just need Fnet. Okay. What are the Fnets? Okay. So the both tension cancels. Okay. And what is causing it to go down is the M2G. So we're going to have the M2G here. M2G. Okay. Then we are going to what is also pulling up against it is that minus mg sine of sine of theta. Okay, which was this part. Okay, then in here there is force of friction. So force of friction is also being pulling down, and that is with mu m normal, which is just mg cosine of theta. So this is minus mu mg cosine of theta, right? So A is equal to all this stuff, m2g minus mg sine of theta minus mu mg cosine of theta. All divide this by m1 plus m2. Okay. There you go. You're not solving for anything. Okay. That's it. So in order for A, so again, in order for this um, to work, okay, you want the top value here to be equal to 0. So people would say that m2 minus m1 sine theta um, hold on. This is interesting. There is a plus. There is a plus cosine theta. No, because if I treat this down, going up is negative. So yeah, this is right. This is minus m2. So there's a mu here. M2 cosine theta. Okay. What you can do is that you can set this all equals to 0. And you can just get that the sine of theta is going to be plus the mu, right? Cosine of theta is going to be equal to m2 minus the ratio of mass 2 over mass 1. Okay, it's the same setup as here before, but I just introduced the force of friction. Okay, all right. The last one is Skydivers Falling. Okay, once the skydiver falls, draw a label all the forces acting on the person. So here you can draw the person if you want. Okay, and here you should draw the parachute, whatever. In reality, make a dot. This is the person. Okay, all right. So going down, this is force of gravity, and going up, and this is going to be force of. It could also be normal, but here we're going to call this the force D. You want to label this because it's not convention. This is the air resistance force, or you can write FD is equal to the drag force. Okay. All right. Give me a moment here. I'm going to give you a little side note. If you're wondering what the convention is that they actually use the letter D here, a big D for the drag force. Okay. But so I spelled that wrong. Force, F-O-R-C-A. Okay. So these are only the forces: force drag up and force gravity down. Determine the acceleration. Okay. So again, it is just F net is equal to ma. Okay. Mass of the person. This is how much they're accelerating. The only force that you have here is that the force of drag. Okay. Please understand that I'm going to treat going down as positive, going up as negative. So you have your force drag, which is negative. Once going down, your force of gravity is equal to ma. They don't like this. They want it in terms of mv, k, and g. Okay. Force of gravity is just mg. Force of drag, no one taught you this, is just kv. So drag force is defined as kv. This is the drag coefficient, and this is velocity. Okay, that equals to mass times acceleration. Okay, if you want this, so this is good, but they want it in terms of acceleration, so divide everything by m. So mg minus kv is equal to m. Double check mv kg. mg kv m. Yep, it's all in terms of that. So that what equals to a. Okay, determine the terminal velocity. Okay, so terminal velocity. This is when acceleration equals to 0, right? That is when the force D force of drag is equal to the force of gravity. Okay, acceleration equals to 0. This is at equilibrium. So I don't know where you want to start. Can I just start here? Is that okay? This is from part A. Okay, I'm not going to start all over. But this becomes 0. Okay, mg minus kv equals to 0. Add kv to both sides. So mg is equal to kv. Determine the person's velocity. You're solving for v. So divide by k, divide by k. You get v equals to mg over, this is ugly. So you get mg is equal to kv divide by k divide by k. You have v is equal to mg divided by k. Sketch a graph of v as a function of time, making sure to label the important values of x and y. Okay, so I haven't taught you this, but it goes back to the kinematic section. Okay, so you want this is going to be time, and this is going to be velocity. Okay, because you're graphing the v as a function of time. Okay, function of time. So this is the time part, and this is the velocity. Okay, so some note is that function of time. So this is the independent variable. The independent variable is also referred to as one on the x-axis. Okay, so that's a very easy way of thinking about it. So, what is the velocity at the start? What is the person's velocity at the start? Okay, is the person zero velocity, or do they have a lot of velocity? Okay, so we will say that the person's velocity starts here. Okay, then they're going to jump off the airplane, and it decreases exponentially. The part that it decreases exponentially right here, this is terminal velocity, which is equal to mg over k that we solve for here. Right? So it goes down. This is this curves. If you understand that, okay, it's not linear. It's not linear. It curves. Okay. So there you go. Okay. As time increases, the object will go down to terminal velocity. Okay. There you go. Those are all your solutions for the free response section.